Hello and good day, pre-algebra. This is Mr. Schultz, and the objective today is to kind of go over each page of this pre-algebra entrance exam review packet that I received in the middle of summer. What am I doing giving you an exam the first week of school? Well, I was told all the cool teachers do, so here we go. First of all, it's kind of going over the purpose of this. You know, 3 months of the summer, it's understandable that you kind of lose some of the things that you learned in sixth grade math, but you know, math is like swimming lessons, where if you've ever taken them, you know that you don't start off in level 4, right? You start off in level 1, and then once you show that you can do the skills in level 1, you move on to level 2, and so on and so forth. And if there are any skills that need to be practiced, then you might not pass. You might have to retake the level over again. And math is kind of the same, is that if we continually just give you information without giving you a chance to prove that you understand it, future math classes are going to be very, very difficult. So these 20 objectives that are in this packet are the 20 most important things that, coming from sixth grade math, you need to know for success in pre-algebra. And if there are any holes, any skills that we need to practice, well, this is your chance to do that. This review packet is optional and will not be graded. You do not need to turn this in. You do not need to show it to me how much you've completed. This is only for your preparation. The entrance exam will take place the first week of school and will be graded on the number of objectives passed. So there are 20 objectives in this packet, which means the entire test is really out of 20 points. Okay? To pass an objective, you have to get 2 out of the 3 questions correct. If you do not pass an objective, you'll need to practice it and retake it before the end of September. Right? You may not use a calculator on this entrance exam, which means even though some of the questions in this review packet you might need a calculator for, or at least make it a lot easier, the questions on the actual exam will be more basic mental math types of questions. So a calculator is not necessary. You may also use a help sheet. I know Mrs. Gambino allowed help sheets on her test as well. You can put definitions, you can put formulas, you can put helpful reminders, anything that's going to help you succeed on the exam. The only thing that you cannot put on there are actually worked out examples. Okay, they are not allowed. For objectives you need to review, you can search for them on Khan Academy, YouTube, the Google, your notes from last year. Hopefully you still have them. But also, hopefully, this video helps as well. Answers to the packet will be sent through Blackbot on Monday, August 29th. And you can always email me, Kevin Schultz at stbp.org, if you have any other questions. So let's begin. I'm not going to go over every question on these pages, just kind of, let's say, you've had them all before. So the purpose of this is just kind of get that light bulb at least flickering again. To where then maybe with a little more research, you can remember how exactly to do it. So just kind of going over the idea, the concept, question or two, then you can take it from there. So CO2, I can add and subtract integers. This is where really your knowledge of a number line is going to be crucial. You know, -3 plus 5, what that means is that you're starting at -3, right? That first number is where on the number line you are starting. The operation is the direction that you're going. In this place, we're adding, so we're going to the right. And that's a bad arrow. And how far are we moving? Well, we're moving 5. Okay? So if you think about it, I'm starting at -3. I'm going to the right 5. Where's that going to lead me? If you need to draw a number line to help you, you certainly can. Here's 0, -1, -2, -3. Here's where we're starting. We're going this direction, we're going 5. So 1, 2, 3 to get to 0, 4, and 5, we end at +2, which would be the answer, right? Number 4 here, -12 minus 2. We're starting at -12. And since we're subtracting, this time, that means we're going to the left. So starting at -12 and going left 2, think about where that is on the number line, that's going to put us at -14. If you thought the answer was -10, well, that would actually be to the right 2 from -12, right? We're going to the left 2, and so -14 would be our answer. Okay? Next objective, we have CO3, multiplying and dividing integers. This one really comes down to paying attention to signs, right? You all know your multiplication and your division facts. And so it's really just, what does it mean if one of those numbers is negative? 6 times -1. Well, the rule of thumb is that if both of your signs are the same, either both positive or both negative, this will result in a positive product or quotient. If one of them is negative, and it does not matter which one, so positive, negative, negative, positive, this situation, either of these will result in a negative product or quotient. So 6 times -1, one's positive, one's negative. You know that 6 times 1 is 6, but because you've got that -1, it's going to be a -6. Okay. Number 5, -8 times -6. You know that 8 times 6 is 48. That fact doesn't change, but because you have a negative times a negative, you know that it's going to be a positive product, positive 48. So really, if you're going to make a help sheet for CO3, I'd recommend putting something like this on it. Again, you will not have a calculator, or sorry, you'll not have a calculator, and so knowing these mental facts is going to be important. Next objective, CO7, comparing, ordering, and rounding decimals. This is kind of 3 concepts all lumped into one. And so for comparing decimals, the one I'm really going to highlight here is number 2, 0.49 with 0.6. So often kids just want to look at the 49 and the 6, and they say, oh, well, 49's bigger than 6, so 0.49 is greater than 6. Well, remember, really, this is out to the hundredths place to match our first decimal. It's really a 60, right? And if you want to, use this method to compare them, ooh, that's a big eraser. 49 is actually less than 60. You could also say that you know that 0.49 is less than 0.6 because 0.49 only has 4/10, whereas 0.6 has 6/10. And 6/10 will always be greater than 4/10. Doesn't matter what comes after it, right? So 0.49 will be less than 0.6. Kind of more practice with this one here, ordering decimals from least to greatest. My recommendation is to use what's called the stacking method, where these are written out horizontally, but look at this vertically: 0.35, 0.42, 0.2. 0.09 and 0.331. Remember that you can add zeros on the ends of a decimal forever. It's not going to change the value. So by aligning these vertically and then filling in, see my longest decimals out to 3 places here, filling in all these zeros to make them all out to 3 places. Well, now we can kind of compare the numbers that we see. This one's going to be the least because it's 90. And then we have 200, and then 331, 350, and finally 420. Right? So that stacking method is a good tool to use to order multiple decimals like you have there. And then round each decimal to given place value, round 0.597 to nearest tenth. Read this place very carefully. 10th, 100th, know your place value coming in. The 10th place would be that 5. So the number that you actually look at to make your decision on does that 5 become a 6 or stay a 5 is the next digit, which is that 9. And since the 9 is between 5 and 9, that 5 would become a 6. Everything else, 9 and everything after it becomes a 0. And to the nearest tenth, this decimal is 0.6. If you want to put 0.600, that's perfectly fine, right? But 0.6 is all you would need. Whoa, call me Tom, because we are cruising. On to CO10. Comparing and ordering fractions. Multiple methods we could use for this one. You could use common denominators. You could think about like test scores. If you got a test score of 8 out of 9, and then 1 out of 6, and then 5 out of 12, I mean, which one of these is going to, get lost in the bottom of your locker, right? Never to be brought home, never to be talked about again. Well, the 1 out of 6, that's pretty bad test score there, right? And then of the two that are left, 5 out of 12 or 8 out of 9, well, 5 out of 12 would be in the middle, and 8 out of 9, that's pretty good. That goes up in the refrigerator at home, right? So that would be the order from least to greatest. If you went with common denominators, you could write all of these with a denominator of 36, looks like to be the first common one. So multiply 9 by 4, 8 by 4, that gives us 32 36ths. Multiply by 6 and 6 gives us 6 36ths. And multiply by 3 and by 3, that gives us 15 36ths. And now since all the denominators are the same, you can just compare those numerators and we would get the same order that we got previously. So you can look at common denominators, you can look at test scores, kind of think about it logically. What you don't want to do, and I see this very often, let me see if there's a good example here that illustrates this. What you don't want to do is look at how far away something is. Sometimes kids will incorrectly, state that 3/4 and 7/8 are the same because they're both, 1 away, right? They're both 1 away. Well, that's a really unreliable method to use because it doesn't always work. And you never want to rely on something that doesn't always work because it doesn't always work, right? If we make common denominators out of this 6/8 and 7/8, we can clearly see that 6/8 is less than 7/8. And so really stay away from thinking, well, how far away are my numerator and my denominator? Because it's a really unreliable method to use. Okay? Next objective, CO12, adding and subtracting fractions. Of course, what are the two things that we must remember with adding and subtracting fractions? Denominators must be the same and denominators must stay the same when you actually do your addition or your subtraction. So 3/14 plus 9/14, we already have those 14ths the same. You're welcome. And so when we add 3 plus 9, 12, and that 14 stays the same, right? Think about denominator of a fraction as like an object, like a thing. You have 3 of something, you get 9 more of something, now you have 12 of that something. That something doesn't change. You have 3 gumballs, you get 9 more gumballs, you have 12 gumballs. The gumballs don't somehow magically combine together, right? You just have 12 gumballs, or in this case, 12 14ths. Do you need to simplify fractions? Yes, always yes, please, yes. Okay, so 6/7 would be the correct answer there. 19/20 minus 1/5. Here we've got to do a little bit of behind the scenes work. Get that common denominator. It's going to be 20. So 19/20 minus 4/20 is 15/20, which would again simplify to be 3/4. You would divide both 15 and 20 by 5 to get there. So those are the things you need to remember for adding and subtracting fractions. The denominators must be the same and they stay the same when you add or subtract. A couple word problems down here at the bottom because why not? But still following the same concept. You should be finding yourself doing something with adding and subtracting fractions here to be successful. CO15, multiplying fractions and mixed numbers. Good news here with multiplication. You do not need common denominators. Okay, multiplying in some ways is actually easier than adding as you get into pre-algebra and algebra because there are less rules, less things to keep in mind. For fractions, all you got to remember is to multiply straight across. 3 times 4 is 12. 5 times 8 is 40. And now we would simplify, divide both 12 and 40 by 4, and that would give us 3/10 as a final answer. You could simplify at the beginning as well. You could simplify vertically there with the 4/8 down to 1/2. It doesn't really matter when you simplify, just so long as you do it, right? That's the important thing, that you do it, whether it's at the beginning or the end. that part doesn't make a difference. When you have a mixed number, like we see here in questions 3 and 4, do convert that to improper fraction first. So a reminder of how to do that. The shortcut is to multiply your denominator by your numerator, and then, your denominator by your whole, and then add your numerator. So in this case, 3 times 2 is 6, plus 1 would give us 7/3, times 4/6. Now we're going to go ahead and multiply straight across, simplify our final answer, and go on with our day. Again, a couple word problems because they're fun. When somebody's drawing a picture, might help. You know, if your grandparents have a large plot of land in Ely, Minnesota, and will divide it evenly among their 8 children, you know, maybe draw a large plot of land in Ely, Minnesota, and draw what it would look like to divide it into 8s. And then your mom, we'll say this is your mom's part here, she says that she will give you a 1/4 of her plot. All right, so if we divide this into 4ths, you get this much here. And the question is, what fraction of the original plot of land does that 1/4 represent? Okay, well, how does this relate to multiplying fractions? Well, basically, you're getting a 1/4 of an 1/8, right? Your mom got an 1/8. You get a 1/4 of that. The word of can mean that you're multiplying. So 1/4 of an 1/8, there's your multiplying fractions. Boom! All right. Next one, dividing fractions. Kind of work through the operations with fractions here. For dividing fractions, you've got 2 options. You can either take that second fraction and flip it. So this would become 3/5 times 9/1. You flip that second fraction and multiply, which means now we're going straight across, 27/5. Or second option, you can keep it as written and use cross products to solve. Either way, you end up multiplying 3 times 9 and 5 times 1. It's kind of funny with dividing fractions. We don't really do any division. we rewrite it as multiplying. And so either way, 27/5 would be our answer. That's fine as a final answer. I don't need a mixed number. Actually, as we get through pre-algebra and into algebra, we use mixed numbers less and less, improper fractions more and more. As long as it's in simplest form, which it is, then that is a perfectly acceptable final answer. Again, any mixed numbers convert to improper fractions first, and then use your process for division. CO19, identify and create equivalent fractions. Write an equivalent fraction of the given fraction. Really open-ended. I mean, there's an infinite number of answers you could have for this. You know, if I take 6/12, writing an equivalent fraction means I want a fraction with different numbers but has the same value. So maybe I want to simplify this. Divide by 6, divide by 6, I get 1/2. 1/2 would be an equivalent fraction. 6/12, maybe I want to double each of these. 12/24 is an equivalent fraction. Maybe instead of multiplying by 2, I want to multiply by 10. 60/120 is an equivalent fraction, right? Each of these would be correct and acceptable answers. As long as you multiply or divide both the numerator and the denominator by the same number, you're going to get an equivalent fraction. To check this, you could take out a calculator, even though you can't use it on the test, but for practice, if you take the decimal value of 1/2, 1 divided by 2, you get 0.5. 12 divided by 24, 0.5. 60 divided by 120, 0.5. So if you check the decimal answers of your fractions, you can verify whether or not they are equivalent. So there you go, equivalent fractions. Next one, CO21, mean, median, and mode, the 3 M's of math. The mean is, when you hear the word average in math, it's typically talking about the mean, which basically means you add all the digits together, all the data together. So it's the sum of all the data divided by the number of data that there is. So for 7, 11, 6, 10, and 6, when you're finding the mean, you're going to add all of these together, the sum of the data, divided by how many there are. There are 5 of them. So that sum divided by 5 would equal the mean. The median is another type of middle. You know, it's not really considered an average per se, but it's a middle that you line up all of the data in least to greatest order. That's the key there. Least to greatest order. And the median is the one that's in the middle, right? That's going to be the 7 here. And the mode is the one that shows up most often, most. So any data that repeats itself, the one that repeats itself the most is going to be the mode. In this case would be 6. One thing with median that you really got to look out for is if they're an even number of data, such as this one, you still want to line them up in least to greatest order. So we have 2, 2, 5, 6, 6, and 9. You know, there really is no single digit that's in the middle here. And so instead, you take the 2 that are in the middle and find the mean or the average of those 2. Okay, so if you have an even number of data, you take the average or the mean of the 2 that are in the middle. That's how you figure out median. Are we about halfway done in here? Where's my... Oh, we're about halfway through. All right. Math 6, 027, plotting in order in... identifying and plotting ordered pairs in the coordinate plane. So half of this, you're identifying a point. This first one, remember, every ordered pair is an XY form. That's why it's called an ordered pair. It's always in the same order. So our x-axis being a horizontal, y-axis being the vertical. This first point right here has an x value of 2, right? 2 right here, up to it, and a y value of 4. 4 on y over 2. So where those two things intersect is that ordered pair. It'd be 2, 4. Kind of like Battleship, except in Battleship you use letters and numbers, so it's a little bit easier, but same general concept. The second half of this is plotting points. So similar thought process. My x got cut off here when I copy and pasted, but the horizontal is the x-axis, vertical is the y. The ordered pair negative 2, 1 gives us an x value of negative 2 and a y value of 1. So I look at negative 2 on my x-axis, 1 on my y-axis, and where those two things intersect is where the ordered pair is going to go. Now, you don't have to draw this every single time. All I would really need is just the ordered pair. You know, my other circles and lines there are just showing you how to get to it, how to get there. But all you would need to do is plot the ordered pair and you'd be done. Find the slope of a line using a coordinate plane. This one kind of requires some user assembly here. It's very difficult to make straight lines in Word. At least it is for me. So I gave you the points, and your job is to connect them, and then find the slope of the line that connects. I can't even make a straight line freehand, for goodness sakes. And then find the slope of the line that connects those points. So what I'm looking for here, if you remember slope, is rise over run, right? And that rise refers to the up or down change. Sometimes it's an upward change, sometimes a downward change. And the run is that horizontal change. You always read a graph from left to right. So in this first one, starting with the point on the left, that's the key, right? Go from left to right. With the point on the left, my vertical change, I'm going down 2. And because it's down 2, that's going to be negative. And then my run, my horizontal change is 3. Down 2 over 3. So my slope would be negative 2 over 3. Rise over run, negative 2/3. For this one, and maybe you don't even want to connect the points, you can just still visualize this here. From my point on the left, I'm going up 7, right? 1, 2, 3, 4, 5. You can't see them counting. Sorry, I'll use a different color. 1, 2, 3, 4, 5, 6, 7 up, right? and then my run, 1, 2, 3, 4, 5, 6 to get there. 1, 2, 3, 4, 5, 6. So a rise of 7, a run of 6. My slope is positive 7 over 6. And this time it's positive because I went up and over to get to my other point rather than down and over. Okay, so finding slope of a line that's been graphed. Next one, I can solve a one-step equation with addition or subtraction. How I teach solving one-step equations, and really any equation, is think about opposite operations, right? We have this variable n plus 5 equals 11. You know, if I want to get n by itself, I want to solve for n, I have to undo the equation. I want to undo what's being done to n. So if I'm adding 5 to n to get to 11, the opposite of that is subtracting 5. Right? And of course, to keep this equation balanced, whatever I do to one side, I have to then do to the other side. So 5 minus 5 equals 0. I've canceled that out. I've got n by itself. Then 11 minus 5 equals 6. N equals 6. You know, and maybe you could do that mentally. If you can, awesome. Right? But this is kind of that process behind it. N minus 8 equals 15. What am I doing to n? I'm subtracting 8. I'm taking 8 from n to get to 15. So to undo that, I can add 8. The opposite of subtracting 8 is adding 8. And of course, I want to do that to both sides of my equal sign. Negative 8 plus 8 is 0. They cancel out. And 15 plus 8 is 23. Well, let's check this. Does 23 minus 8 equal 15? Yes, it does. Right? You can check these very, very easily by plugging your value back in for the variable in the equation and seeing if it works. The next objective, one-step equations with a multiplication or division, is very similar. You know, 7n equals 35. What does that mean? Well, in math, whenever you have a number followed by a variable, the operation is that you're multiplying. So what this says is 7 times n equals 35. 7 times what number equals 35? Or 7 of what number equals 35? Well, the opposite of multiplying by 7 is dividing by 7. So just like in the previous one, I'm using opposite operations here. I have 7 n's. I divide by 7. 7 divided by 7 equals 1n, which is what I want. Right? I have 7 n's. I divide them into 7 groups. Each group has 1 n. I have 35 divided into 7 groups. 35 by 7 is 5. And does 7 times 5 equal 35? You bet it does. Okay. When you have like a number 3, division here, n divided by negative 8 equals 4, that means I'm taking some number, dividing it by negative 8 to get to 4. Maybe this one isn't quite as easily to do mentally. So relying on opposite operations, what's the opposite of dividing by negative 8? Multiplying by negative 8. These cancel out. N is by itself. And 4 times negative 8 equals a negative 32. Let's plug it back in. Does negative 32 divided by negative 8 equal positive 4? Yes, it does. So I know it checks out. Okay. You see some fractions here? Don't be afraid of fractions. The fraction bar is really just another way to write division. Right? Number 4, n over 3 is the same thing as n divided by 3. Right? So if that operation is division, what would you do to undo dividing by 3? You'd multiply by 3. So make sure you do it to both sides. Next objective. Find a percentage using an equation. All these are kind of set up the same. You're given a part, you're given a whole, and you're looking for a percent. So if you remember that the word percent per 100 literally means out of 100. Your formula or your equation is part over whole equals your percent out of 100. And in all of these, you're given the part, you're given the whole, right? Whatever follows of, that's going to be your whole. And then the part that you have is the part. You're solving for the percent. So this first one would be 10 over 25, part divided by whole, equals what over 100? And a couple of different methods you could use to solve this. You could use cross products, okay? But this one's really set up for a scale factor. How do I get from 25 to 100? Multiply by 4. So I do the same thing to my 10, multiply by 4. 10 times 4 is 40. My answer is 40%. Okay, and in fact, I think all of these are set up so that you can get to 100, yes. You can use scale factor to get to 100. 1 is what percent of 20? Here's my part. Here's my whole. My formula, part divided by whole equals percent over 100. So I've got 1 over 20 equals percent over 100. How do I get from 20 to 100? Multiply by 5. So I do the same thing to my numerator. 1 times 5 equals 5. 5% is my answer. Speaking of cross products, I think that's what CO49 jumped into. Yeah, I can write and solve proportions using cross products. You can read 20 pages in 30 minutes. How many pages can you read in 90 minutes? The most important thing with setting up a proportion is making sure your units match. 20 pages and pages. 30 minutes and minutes. So my proportion could be 20 pages in 30 minutes equals n pages, right? That's what we're solving for, in 90 minutes. When I say make sure your units match, notice how my units are matching going across. Pages over minutes equals pages over minutes. You might do it minutes over pages equals minutes over pages. That's okay. You might do pages over pages equals minutes over minutes. That's okay too. They can line up vertically. What you don't want is pages and minutes and then minutes and pages. This is incorrect. Do not do this. They cannot line up diagonally. Okay, if you can make an X with your units, then X it up, right? Because that's not going to be correct. So doing this now, you could use scale factor here from 30 to 90, but in the spirit of cross products, I'll do it using cross products. So we have 20 times 90 equals 30 times our variable, 30 times n. 20 times 90 is 1800. And now I'm kind of back to a previous objective, actually, where I've got a one-step equation to solve here. 1800 divided by 30 gives me 60. So if I can read 20 pages in 30 minutes, I can read 60 pages in 90 minutes. The nice thing about proportions is that there are a lot of different ways to set them up and a lot of different ways to solve them. Okay, so kind of whatever you understand best, whatever makes most sense to you, okay, do it that way. 3 bananas cost $1.50. How much, there's our unknown price, will 10 bananas cost? So 3 bananas for $1.50 equals 10 bananas for how much money? Bananas over price equals bananas over price. And then cross products to solve that. Okay. What do we got next? We've got, perimeter and area of rectangles and squares. Fantastic. Remember, perimeter is the distance around something. If you ever watch crime shows and they say, secure the perimeter, right? It means that they want to secure a certain boundary around a building or field or whatever it is, right? That distance around something. Area is like the space inside of an object, right? So for this first one, the perimeter, you would want to add all the sides together. 32 plus 20 plus 32 plus 20, as if you're putting up a fence around this rectangular yard. And area would be base times height is the formula for a square or rectangle. So the base being 32 times the height 20, that would give you the area of the figure. Okay? Remember, that in a rectangle, not all sides need to be labeled. If you know it's a rectangle, you know that both bases will be 8, both heights there will be 5. And in a square, what makes a square special is that all the sides are the same. So if we have this one side is 7, especially with these markers here, those are the congruency markers for a square or any shape. It means all sides are 7, right? And then the process for finding perimeter or area is the same. Identifying triangles by its angles and its sides. For this one, this one is mostly just, do you know what those definitions are? Do you know what an acute triangle is? Well, it's a triangle where all 3 angles are acute. And so when it says draw and label an example of an acute triangle, well, I see the triangle, but how do I know it's acute? I need labels. 70, 50, 60. Do the angle measures matter? You bet they do, right? Because how many degrees are in every triangle? The angles have to add up to 180 degrees in a triangle. So when you draw and label your right triangle, tell me it's a right triangle with labels, okay? Geometry, it's really important to label things. I can see the triangle, but how do I know it's acute? Label it. Then we get talking about sides as well, so you might need to look up these words, what is scalene, what is isosceles, what does equilateral mean. But again, when you label it, how do I know it's a scalene triangle? Don't just say, well, look at it, right? Show me with the labels. Missing sides of similar polygons. So what does it mean for similar polygons? Well, it means that their corresponding sides are proportional. Right? Corresponding means like the same location. So in this first one, are the 2 figures similar? Explain why or why not. The corresponding sides, 8 and 18, are in the same location. 12 and 24 are in the same location. So when I set up my proportion to see if they're proportional, I have to look at corresponding sides. 8 is to 18 as 12 is to 24. And again, there are a number of different ways you could set this up, right? This is just one option. But does 8/18 equal 12/24? Well, 12/24 I know is equal to a half. Is 8/18 equal to a half? It is not. So these are not equal. And so they are not similar figures. Okay? So you're picking 2 pairs of corresponding sides and comparing those proportions to see if they are similar. Whoa, no! I just closed everything. Oh my, hold on. My fat finger took down the whole document there. Listen, pick up where there we go. Down here, okay. So you are picking corresponding sides to see if they are proportional. Probability of a single event, the formula to calculate the probability of a single event, the probability formula is successful outcomes over possible outcomes. Okay, probability is a fraction, which means it can be written as a percent. And so if the numbers 1 through 20 are place, who's my editor? Fired. Placed in a hat, what is the probability of choosing an even number? Okay, well, how many even numbers are there? How many successful outcomes are there if the numbers 1 through 20 are in a hat? Well, 10 of those numbers are even, so there are 10 successful outcomes. How many possible outcomes are there? How many numbers could I choose? 20. So 10 out of 20 would be a probability of 1 over 2, which if you wanted to write it as a percentage, 50% chance. Okay? What is the probability of choosing a number greater than 17? Well, how many numbers are greater than 17? 18 is greater, 19 is greater, and 20 is greater, right? 3 successful outcomes out of how many possible outcomes? There are still 20 numbers in the hat, so 3/20ths, 3 out of 20. This can't be simplified, but if you did want to write it as percentage, you wouldn't have to. But if you did, it'd be 15%. Okay? So that is your probability. And last but not least, it is the last but not least, isn't it? Yes, it is. Use the counting principle to find the number of possible outcomes of an event. Mrs. Gambino last year showed you 2 outcomes, or two methods to find the number of possible outcomes. One was the probability tree, which always gets received with a lot of complaints because it's a lot of work, and it is, which is why we have another method called the counting principle. Okay, and my advice for looking at the counting principle, you essentially want to combine all the outcomes for each event. So we're going to make an event outcome chart. If you flip a coin twice, there are 2 events there, right? You flip a coin once, that's an event. So flip 1, and then you flip it again. That's a second event. Flip 2. Now, how many outcomes are there for the first flip? You can get heads, you can get tails. There are 2 outcomes. How many outcomes are there for the second flip? You can get heads, you can get tails. There are 2 outcomes there again. So how many total outcomes are there for flipping a coin twice? Well, now these 2 2's get multiplied. 2 times 2 means there are 4 outcomes. And this one's small enough where we can actually write what those outcomes are just to prove it to you. If you flip a coin twice, you could get a head and a head. There's 1 outcome. You could get a head, then a tail. Second outcome. You get a tail first and then a head, third outcome. Or you can get a tail and a tail. Right? When it's these few outcomes, it's not too difficult to write them out and see, oh yeah, that makes sense. It's 4. When you get to some bigger stuff though, this event outcomes chart can be really quite helpful. Let's look at, you are choosing an outfit from 3 pairs of pants, 1 outcome, 3 shirts. Who is this editor? Shirt? No, shirts. Another outcome there, or another event there, and 5 ties. So how many events do we have? In our event outcome table, we now have 3. We have pants, we have shirt, and we have a tie. Well, how many outcomes are there for picking the pair of pants? I've got 3 pairs, which means there are 3 outcomes. How many outcomes are there from picking a shirt? I've got 3 shirts, which means there are 3 outcomes. How many outcomes are there from picking a tie? I've got 5 ties, which means there are 5 outcomes. These numbers all get multiplied together, and 3 times 3 times 5 equals 45 possible outcomes. With 45 outcomes, I don't really want to be writing out all those different possibilities. That gets to be kind of a lot. So this counting principle is a really, really handy tool. It's a fairly organized way, especially if you use this table to get that number of possible outcomes. So that wraps up our pre-algebra entrance exam review. Hopefully most of this stuff, like, oh yeah, I got that, I remember that, but if there's anything that you didn't get during the year, and you still don't get it now, take the time to practice it, make a help sheet for it. If you want to contact me, please do. The answers will come out on August 29th. If you're watching this on my YouTube, channel. Lessons during the year will be posted here. So if you ever miss anything, if you're ever absent, this is the place to look to see what you missed. And of course, don't forget to like and subscribe. I look forward to meeting you at open house or the new family barbecue or the first day of school, whenever our paths first cross. It will be a highlight of my day. Thanks so much for watching. Bye. Oh, hold on. That was supposed to be much, much smoother. Let me use my mouse. Okay. Bye.